Hey, good afternoon. This is René Klomp. What I'm trying to do with this new video, I'm going to show you how I've set up Kubernetes cluster with, as you can see at the bottom right, with 5 nodes. So we have a master node, which is this one on the left, and then we have 1, 2, 3, 4 worker nodes that will actually do the work. So we'll have atoms deployed and so on and so on. So in the next series of videos, I will show you some of the scaling capabilities, failover capabilities, auto-scaling capabilities, and so on and so on. So having said that, let me show you a little bit around here in the platform. So I'm logging into the platform in my own account here, and if I go over to manage atom management, what you can see on the screen is a bunch of environments. Now this one's going to be the most exciting one. So for this video, I've set up a Kubernetes environment that will take the atoms once they get deployed, depending on needs. They will get attached to the Kubernetes environment here. So later on, once we have some atoms, one or more atoms deployed, we will be installing or using some processes that I've built here as well in this Kubernetes folder. So there's going to be this process that's going to be the main process, which is actually a service-enabled process that I'm going to call with a lot of users to spike up the HTTP request rate and in that sense cause auto scaling of the whole cluster. You'll see that later on. Right, so in order to do that, I've made a somewhat compute intensive job here just to spike up the CPU percentage basically, and then giving back a message. And actually it's a standard message, just a dummy message. And for those who know the patient API demo, will recognize the data here that it's getting back. Okay, very simple. So let me go back here to atom management real quick and show you what I have done on the Kubernetes cluster side. So I'm starting my command prompt and logging into the master node. So pi-add master. And if all good, we can log on with the standard password here, and we end up in the actual master node, as you can see. Now, let me just show you a little bit around here. So loads of the commands that you can give with kube control, like getting your pods, getting your nodes, getting more info about your nodes. And let me actually do that one. So kube control, get nodes should give back the information as I've just showed you on the small video there. So that's my master node and the 4 worker nodes that are ready to take, an atom for further processing of whatever, probably in this case API calls, right? So what I'm going to do is show you around a little bit more, going into my YAML directory, which will have the configuration of various deployments. And the one we're looking at in this video will be an atom deployment with according services and some stuff around auto-scaling, which I'll talk about later on. Now I'm actually going to show you this one because it has my password blanked out, so I don't have to worry about that. So if I go into this one, what you'll see, so it's a deployment description or configuration, an atom deployment. In fact, I call the app atom. Obviously, as you can see, it starts with 1 replica. So 1 pod having 1 atom here. And it's using a Docker container, right, that I've set up or actually made for Raspberry Pi. As you can see, I didn't say it yet, but these are 5 Raspberry Pis. So they will take the actual atom or the atom as part of a container. And I had to sort of build those for the Raspberry Pi architecture. Okay, so what is interesting to note here is the life cycle of the atom, the pod, so to speak, which I have made 2 options here for the lifetime of the atom within the pod. So first of all, I have set something up where I am, once the pods get destroyed, just before that, so pre-stop, I can delete the atom altogether, right? So it will be actually deleted. There will be no reference to the actual atom ID. So the next time you will have to create a completely new one, right? And then there's this option of detaching an atom. So the actual files that are shared with the node, the worker node file system will stay there, and the next time you can reattach them, and you will have access to the same atom, more or less to the same atom with the same atom ID. Right. So having said that, you see a lot of configuration that is standard for Docker / Kubernetes. So having my reference back into the platform, my username, password, obviously the URL to the actual platform, and so on and so on. Now, what I did here is instead of having every atom having the same name like pod, which is totally meaningless, and especially when I'm going to auto scale and scale up, I would like to see what atom is taking the work. So I took this value for the name of the atom from the node name. So hopefully once we deploy our first atom, you'll see that it should be like worker 1, worker 2, worker 3, or worker 4. So all good. Then the environment ID obviously should correspond to my, let me check that, double check here. Here you go. So the ID of the environment here, which is pretty cool. And then obviously the service that I've set up, that I have also given an external IP, which is the IP in my internal network that I can go to on this port to access my API that I've just described, right? That will kick off the process that I showed you. Okay, so all good. Let me do my first deployment here. So I'm just picking from history here, if you don't mind. So I'm going to look at let me pick here on on this one. So I'm going to create a deployment based on my YAML file that I just described to you. So -f taking this file, and I'm going to create something there. So let me do that. So we get back the deployment of the atom has been created, and also the service has been created. Now going back into not a get nodes, but let me show you a pods. So as you can see now, we have something here now since 14 seconds running. So this is my first deployment called atom deployment, and then some identifier, which is now ready and is already running. Now, obviously it has to be installed somehow. Let me switch this over here. And at some point in time, we should see the actual atom being, present within the platform as well. We'll start calling back the platform, and you should see it there. And actually, it should be attached to the Kubernetes environment. Now, let me also show you the actual services. Let me see if we have that already. So there's my Kubernetes native thing. We're not going to talk about that. This is my atom service here. So you can see it's not based on an actual external load balancer. It's using a cluster IP with this external IP that I talked about. So we should be able to call the actual service by calling this external IP on this particular port once the atom has been set up. So let's just wait a couple of seconds more before I start going any further with this. Now, what I can do also is get pods, as you can see in the history, and using output wide. There you go. The atom is now here, right? It should be attached shortly. But if I click kube control get pods -output wide, what you can see is this atom is deployed on this node. So that's worker 04. And as I've said before, the name of the actual atom is gonna be like that. So it's gonna be named worker -04, as you can see here. And there you go. So it's all good. It's running. It's attached to the Kubernetes environment. Having this host name doesn't really matter. Having a unique atom ID, obviously, and we're ready to to deploy stuff to this environment. This is Kubernetes environment. And as I've said, the process that I showed you is actually deployed to this environment, so should automatically be deployed to this environment, as you can see. So there's my Kubernetes test process that we're going to use later on. Right? And actually that should show a listener here as well. I don't know why that's not. There you go. So here's my Kubernetes test process listener. It's part of the web services server. So all good. We should be able to actually trigger the process by just making one request here. So let me try to find my curl statement. Let me see if that works. So if I go curl HTTP and then now the external address, so that should be something like this, port 1990. And it's a simple web service. It's not an API as such. So that ID, let me see what that gives back. I said, there's some calculation being done just to spike the CPU usage, but in the end, I will get back, as expected, the patient information data, which is really cool, right? So I showed you how to deploy an Atom using Kubernetes and the Atom based on a Docker container, and how that will be automatically be proficient with the processes and APIs that I have set up for it. Thanks.